Hello students, in this class we will learn about sequence and series. Okay, so what do you mean by sequence? Sequence means the arrangement of some numbers where every numbers are related by some mathematical relation. Okay, now if we represent those number means the numbers which are formed that sequence by the form of addition, then we can say that representation, that means the summational representation will be known as series. Okay, so let us study about sequence and series. Definition. When some numbers are arranged in order where every term is defined by some mathematical relation, then that arrangement is known as sequence. Okay, so when some numbers are arranged in order where every term is related, where every term is defined by some mathematical relation, then that arrangement is known as sequence. Example. One by two, 1 by 3, 1 by 4, 1 by 5, continue. One by two, 2 by 5, 3 by 10, continue. So these are the example of sequence. Why these are the example of sequences? Because in the first example, every term, that means half, 1 by 3, 1 by 4, 1 by 5, continuing, follows some mathematical relation. So what is the mathematical relation? Here first term A1 is equals to 1 by 2, second term A2 is 1 by 3, third term A3 is 1 by 4, fourth term A4 is 1 by 5. That means 1 by 2 means 1 by 1 plus 1. 1 by 3 means 1 by 2 plus 1. 1 by 4 means 1 by 3 plus 1. 1 by 5 means 1 by 4 plus 1. That means when number of terms is 1, that is first term, then this is 1. For the second term, this is 2. For the third term, this is 3. For the fourth term, this is 4. Now, if this arrangement continues up to n terms, then nth term, that is an, will be equals to 1 by n plus 1, where small n belongs to capital N. This notation denotes belongs to, and capital N denotes set of natural numbers. Okay. So, if we follow example 1, then every term is related by this mathematical relation. That is, its nth term an is equals to 1 by n plus 1, where n denotes natural number. Okay. By this relation, if we put n equals to 1, then this will be a1. a1 equals to 1 by 1 plus 1. Then a2 is equals to 1 by 2 plus 1. a3 is equals to 1 by 3 plus 1. And a4 equals to 1 by 4 plus 1. Okay. That is why we can say the example 1 forms a sequence. In example 2, first term a1 is equals to 1 by 2. Second term a2 is equals to 2 by 5. Third term a3 is equals to 3 by 10. That means we can represent this denominator 2 as 1 square plus 1. This as 2 by 2 square plus 1. This as 3 by 3 square plus 1. If these values continues up to n term, then n will be equals to n by n square plus 1, where small n belongs to the set of natural number. Okay. That means in example 2, every term follows this general mathematical relation, that is n equals to n by n square plus 1. That means for the first term, that means when n is 1, then we have a1 equals to 1 by 1 square plus 1. That is why we get a1 equals to half. For the second term, we have n equals to 2. That is why a2 is equals to 2 by 2 square plus 1. For the third term, n is equals to 3. That is why a3 is equals to 3 by 3 square plus 1. Okay. So, these two examples describes the sequence. Okay. So, sequence means the arrangement of some numbers where every number is related by some mathematical relation. Okay. Now, if we represent these terms, that means the terms which are in a sequence, that means which form a sequence by the form of addition, then this will be known as a series. Okay. Now, the terms present in a sequence are represented by the form of addition or summation, then the new arrangements will be known as series. Okay, so now the terms present in a sequence are represented by the form of addition or summation, then the new arrangements will be known as series. For example 1, series will be 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus continuing. For example 2, series will be 1 by 2 plus 2 by 5 plus 3 by 10 plus continuing. Okay. So, when the numbers present in a sequence is represented by the form of addition or summation, then that new arrangement will be known as series. Okay. Now, we will learn about some special series. So, those special series are arithmetic progression and geometric progression. Okay. So, let us study about arithmetic progression. Special type of series or progression are number 1, arithmetic progression or AP. Geometric progression or GP. Third, harmonic progression or HP. So, some special type of series or progression. Why this series is also known as progression? Because this series is also known as progression as every value is progressed. That means a new value or new term is generated by depending some mathematical formula. Okay, that is why and in this case always we consider every term is different from the previous term. Okay, so every term generates by following some mathematical relation. That is why this the another name of series is also progression. Okay, so some special type of progression are arithmetic progression or AP, geometric progression or GP, harmonic progression or HP. Now we will learn about arithmetic progression. Okay. 1, 2, 3, 4, continue. 7, 10, 13, 16, continue. Minus 10, minus 12, minus 14, minus 16, continue. Now we take some examples. What are the speciality of these examples? Now we will study about those speciality. If we follow this example 1, then 2 minus 1 will give 1. 3 minus 2 will give 1. 4 minus 3 will give 1. That is, in every case, the difference is 1. If we follow the second example, 10 minus 7 equals to 3. 13 minus 10 equals to 3. 16 minus 13 equals to 3. That is, in every case, the difference is 3. If we follow the third example, then minus 12 minus of minus 10, that is minus 12 plus 10 will give minus 2. Minus 14 minus of minus 12, that is minus 14 plus 12 will give minus 2. Minus 16 minus of minus 14, that is minus 16 plus 14 will give minus 2. That is, in every case we have minus 2 as the difference. Okay. So in each example, if we follow, then we can see that any term minus its previous term always gives a fixed value. That is, for the example 1, 2 minus 1 will give 1, 3 minus 2 will give 1, 4 minus 3 will give 1. Okay, that is, every term minus its previous term always gives a fixed value. For example 2, 10 minus 7 will give 3, 13 minus 10 equals to 3, 16 minus 13 equals to 3. That is, any term minus its previous term always gives a fixed value. If we follow example 3, then minus 12 minus of minus 10 will give minus 2. Minus 14 minus of minus 12 will give minus 2. Minus 16 minus of minus 14 will give minus 2. That is, every term minus its previous term will gives a fixed value. Okay. So we can generalize the formula for these three examples. So this generalized formula or generalized definition can give us the definition of arithmetic progression or AP. So what is that definition? If a series of value progressed in such a way that any term minus its previous term, any term minus its previous term always gives a fixed value, then that progression is known as an arithmetic progression or AP. Okay. So, if a series of value progressed in such a way that any term minus its previous term always gives a fixed value, then that progression is known as an AP. Okay. In these three examples, we observe any term minus its previous term always gives a fixed value. That is why we can say these three examples are the examples of AP. Okay. The fixed value that is any term minus its previous term is known as common difference. Okay. So, here what is the common difference? The common difference is any term minus its previous term, that is the fixed value. For this example 1, common difference is equals to 1. Second term minus first term equals to 1. Third term minus second term equals to 1. Fourth term minus third term equals to 1. That is why common difference is 1. For example 2, common difference is 3. Second term minus first term will give 3. Third term minus second term will give 3. Fourth term minus third term will give 3. That is why common difference is 3. For example 3, common difference is minus 2, because second term minus first term is minus 2, third term minus second term is minus 2, fourth term minus third term is also minus 2. Okay. So, the fixed value, that means any term minus its previous term of an AP is known as common difference. Form of an AP is A plus D, A plus 2D, A plus 3D. Continue. Where first term A1 equals to A, second term A2 equals to A plus D, third term A3 is equals to A plus 2D, fourth term A4 equals to A plus 3D, where common difference equals to D, as A plus D minus A. equals to a plus d minus a equals to d. A plus 2d minus of a plus d, that is a plus 2d minus a minus d. 2d minus d will give d. Okay. So here the common difference is d. So if we follow these terms, that means first term, second term, third term, fourth term, we will get some relationship among these terms. Okay. So what is that relation? For the first term, we can write a plus 1 minus 1 into d, because 1 minus 1 will give 0, 0 into d means 0. So that is why a plus 0 will give a. So we can represent a by this form. For the second term, a plus b can be written as a plus 2 minus 1 into d. As 2 minus 1 will give 1, 1 into d will give d. So a plus d can be written in this way. Similarly, we can represent third term a plus 2d as a plus 3 minus 1 into d. Fourth term a plus 3d as a plus 4 minus 1 into d. Okay. So if we continue this progression, then nth term an can be written as a plus n minus 1 into d, where n represents number of the term. Okay. So this is the general form by which we can find nth term, or you can say any number of term, the value of any number of term of an AP. So this is the formula by which we can find the value of any term of an AP. Okay. Now, if A, B, C, that means these three numbers are in AP, then from the definition of AP, we can write B minus A is equals to C minus B. Which will give B plus B is equals to A plus C. That is why 2B equals to A plus C. So if three numbers ABC are in AP, then we can write this relation, that is 2B is equals to A plus C. If three numbers are in AP, then we can let them as P minus Q, P, P plus Q, as P minus of P minus Q is equals to P minus P plus Q is equals to Q. P plus Q minus P that is P plus Q minus P. Cancelling P, we will get Q. Okay. So when three numbers are in AP, then we can let them as P minus Q, P and P plus Q. If four numbers are in AP, then we can let them as A minus 3D, A plus D, sorry, A minus 3D, A minus D, A plus D and A plus 3D as A minus D minus of A minus 3D is equals to A minus D minus A plus 3D, cancelling A 2D. A plus D minus of A minus D is equals to A plus D minus A plus D will give 2D. Okay. Continuing this, we can find A plus 3D minus of A plus D. This will also give a 2D. Okay. So when four numbers are in AP, then we can let them as A minus 3D, A minus D, A plus D and A plus 3D. If five numbers are in AP, then we can let them as A minus 2D, A minus D, A plus D, A plus 2D. Okay. So if five numbers are in AP, then we can let them as A minus 2D, A minus D, A plus D and A plus 2D as A minus D minus of A minus 2D, that is this second term minus first term, A minus 2D, sorry, A minus D minus A plus 2D. This will give D. If we continue this, that means A minus of minus D, that is third term minus second term, this will also give D. A plus D minus A, that is fourth term minus third term, will also give D. A plus 2D minus of A plus D will also give D. Okay. So if five numbers are in AP, then we can let them as A minus 2D, A minus D, A plus D and A plus 2D. Okay. So these are some assumptions. We have to consider these assumptions when we solve our problems. Okay. So these assumptions can help us to find more easier when we want to solve any kind of problems. Okay. In our examples, we will study about these applications. Okay. So let us study about some examples how we can solve some numerical values, or we can find some numerical values when AP is given. Okay, when an AP is given. Two problems. In these two problems, we have to check these progressions are AP or not. Okay, so to check these are AP or not, we have to follow the definition of arithmetic progression. Okay, solution. For example 1, we have 3 plus 6 plus 12 plus 24 plus continue. So here A1 equals to 3. A1 means first term. A2 equals to 6. A3 equals to 12. A4 equals to 24. So A2 minus A1, that is 6 minus 3 equals to 3. A3 minus A2, that is 12 minus 6 equals to 6. A4 minus A3, that is 24 minus 12 equals to 12. Since A2 minus A1 is not equals to A3 minus A2, not equals to A4 minus A3, that is any term minus its previous term never gives a fixed value. So the given example, so the given series is not an AP. Okay. So in first example, we observe A2 minus A1, A3 minus A2, A4 minus A3 will never give a fixed value. That is why we can conclude that the given series of value is not an AP. For example 2, we have A plus B plus within second bracket A plus 1 plus B plus within second bracket A plus 1 plus B plus 1. Continue. So here first term A1 is A plus B. Second term A2 is A plus 1 plus B. Third term A3 is A plus 1 plus B plus 1. So A2 minus A1 is equals to A plus 1 plus B minus of A plus B. That is A, removing all the brackets, we can write A plus 1 plus B minus A minus B. Cancelling B and A, we get 1. A3 minus A2. A3 means A plus 1 plus B plus 1 minus of A plus 1 plus B. Removing all the brackets, we can write A plus 1 plus B plus 1 minus A minus 1 minus B. Cancelling B, A and then 1, we will get 1. Okay. So in these two cases, that means A2 minus A1 and A3 minus A2, we get 1 as the difference. So A2 minus A1 is equals to A3 minus A2, imply any term minus its previous term gives a fixed value. Thus, we can conclude that the given series is an AP. Okay. So, if when we follow example 2, then we observe that A2 minus A1, A3 minus A2 gives 1. That means A2 minus the value of A2 minus A1 and A3 minus A2 is a fixed value. So, that is why we can conclude that the given series is an AP. Okay. In our next class, we will study how we can find any number of term and the problems related with AP.